If you understand, you don't understand, go and read it up. But in this case, this is industry. So I know we're also having lots on our table and lots reading. So that's why we're going to take more time for us to understand. And sincerely, once we get the full grasp of the basic, like this period, then the other knowledge we're building on top will not be burdensome or will not be boring. So we're going to take a little review. So the little review we'll taking, we'll start our review from uh, storing data into Adobe system, what we did then, because that's the next practical class you'll be working on Friday. So you're working on storing data into the Adobe file system. You'll be working on the H-based commands, and we'll talk about working with MapReduce or Yarn, customizing MapReduce execution. So all those guys had their practical class. So I just want us to refresh our memory with what we should expect. Hello? Somebody's talking.
Sorry.
Yeah. Okay. Is somebody talking?
Yes, I was the one. I didn't know I was not on mute. I'm sorry.
All right. No, bad one. Okay. So, and we were talking about working with MapReduce on Yen, and I think we did a lot on the MapReduce with Tabular and customizing MapReduce. That was our last class. So we just have three classes to review today. Before we move past this session. In the current modules we are currently treating, we still have two more topics to treat, and that is testing and debugging MapReduce application. So that's what we should do today. So if time permits us, we'll conclude our class with maybe testing and debugging MapReduce application and working with here. But before we move to that, let's talk about storing data in Hadoop distributed file system. So we're just going to have this is just a recap session, and this is a time you can ask more questions so that when you're working through the practical class you can understand. To me, the practical class is more simpler than the theoretical session. So me, I enjoy practical class. So okay, a brief recap on storing data in Hadoop. We said something about how HDFS works. We talked about HDFS federation. We talked about architecture and role of HBase. We talked about the characteristics of HBase schema. And we talked about the basic programming for HBase, and we talked about the capability of HBase and HDFS for effective data storage. So I would like somebody to remind us on, say, just explain, like, all our classes have been HBase, HDFS. So now explain HDFS to us and how to work with HDFS. So I'm going to call like 3 people to explain those topics before I finalize it. And the first 2 will be Akomolafe and Ebube. So Akomolafe. Akomolafe.
No, sir, can you hear me?
I can hear you.
Hello.
Hello, I can hear you.
Okay. So HDFS, like we've been saying over time, is one of the components of the Hadoop ecosystem, and is the file system of the Hadoop ecosystem. which enables files to be stored in clusters, such that when one file has been stored, it 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 can only be replicated once. It cannot be replicated twice. You understand? And it's also it has a name node, and it could have several data nodes, which the name node is just like master, which coordinates all other activities of the data node. And the HGFS is it also operates in such a way that it keeps records. It keeps like records and logs of the activities that is carried out on the system, and is basically is the file system is one that coordinates the file system of the whole Hadoop ecosystem, which has to do with how files can be created, how they can be moved, how the access location, how we can access the files, and so basically that's what I can say about HDFS. Then if I would talk about HBase, I don't know HBase. I think we talked about HBase. HBase is is also one of the components of the Hadoop ecosystem that enables us to how do I put it, for should I say data entry in a columnar base, in a column base and it's such that when data is being, or when there's an entry into the HBase, it can be it can be it can be, it allows for entry or not it allows for entry in the real sense, and it also allows for it to be deployed for use, in the sense that we can have access to it when we are logged in into the HBase terminal and all that through our what do you call it, through our Linux terminal. So, that's what I can say, sir.
Okay, that's fine.
Yes.
So I'm gonna add little.
Okay,
just to complete, I'm just gonna add little, or let me say reiterate what you said. I was gonna add little, then everybody will pick it from there. So, like, HDFS has been the talk of the town, and I remember when I was talking the last time we had the class on this, I said HDFS you should see it as a window, like a normal window, like where every other thing sits on, but it has ability to distribute itself. When you run a window, a Windows system can only work on the machine at a time. So a Windows operating system has a functionality. A Windows operating system has a functionality to manage a singular PC at a time. But an Hadoop file system has the functionality to distribute itself across different nodes. And it knows how to engage all the nodes in such a way that it doesn't get angry when one is down. So like if one of the nodes is down, the HDFS system still understand and say, okay, you guys, you are down, then okay, the rest guys keep working and distribute the work for them. So, and one of the attributes we talked about is the ability to replicate files, like so that it's sure that, okay, I know I don't trust all of you, so you keep a copy, you duplicate I'm going to duplicate record across you guys, such that in a way that when a file, or when one of you goes down, the other guy that is having a copy of the file picks the file up and continues the job from there. So that's fine. And we talk about possible limitation of Hadoop HDFS, which is that not just any application can work on Hadoop. So like when you have on Windows, any application you can just say, okay, let me write a programming, let me write a window application to work on Hadoop, but in Windows. But in Hadoop file system, not all applications can interact with Hadoop file system. So because not all of them has the capacity to distribute themselves as Hadoop file system will require them to do. So that's that. So I think I've just done a lot of summary. So I think Marvelous also talked about HBase, and sincerely, the interesting part of HBase is what he said, the columnar database. Yes, 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 yes. I have a mental picture of how that table looks like, and that makes it very efficient to work with. And we talk about the parent key of for an HBase, which makes it very easy to use. These things, why we are reiterating them is because in our next class, you'll be having the practical sessions on them. So you see HBase, how we import data into HBase environment, and how the colonial stuff looks like, how you can put, how you can scan, and the likes, how you can perform your operation on your HBase table. So that's fine. So Ebube, I would like you to talk about federation on HBase. So we'll talk about federation during our last class too. So tell us about federation. What led to federation, and what's the concept? What's the architecture behind HDFS federation? That's the question, Ebube.
Yeah, hello.
Hi.
Okay, if I remember, I think the H no, is it HBS Federation or HDFS? I know about HDFS Federation.
Is HDFS federation? We don't have HBase federation, or unless maybe we are developing that.
Okay. Okay, well, I think it was developed to enhance scalability of the namespace. Basically, the benefit is for namespace scalability, where I can't really remember, I won't lie to you, but I know that one of the benefits, very important benefits, is namespace scalability. All these are not, I've not really gone through everything like that, but this is what I can really remember about HDFS Federation for now. So I don't really know, I can't remember everything here.
So everybody call a friend.
Call a friend. Can I call Marvelous again?
Everybody.
I said, can I call
Call a
Marvelous?
friend. You want to kill him?
Okay, sorry.
Call another person.
Okay, Hubert.
So who are you calling?
Hubert.
Okay. All right, Hubert. He's not responding, no. Hubert, are you there?
Okay, let me call on that person. Hello, can I call someone else?
Yes, you're free. It's your call.
Oh, okay. Adeto. Adeto. Are you there?
Hello, sir.
Yes,
I'm here.
Okay, Esther. Oh yeah. Bail your friend. Your friend is on the hot seat, and he needs you to bail him out.
Sir, I really cannot remember what I know you mentioned it, but I can't remember what it's about.
Okay. Uh, I wish I can see you guys and give you guys two punch each. When we were in primary school, they beat us. But me, oh, it is punch I use. So don't worry, one day I will see you guys and I will revenge all my punches back from you guys. I need to call a friend.
Sunday.
Sunday Ogunleye.
Yes. If Sunday is not available, then Yola Daniel.
Okay, hello.
Okay,
Okay, Sunday is available.
Yeah. What I understand by AGFS Federation is, I think that's the question, right?
Yes,
Yes.
that's it.
Okay. It's just the way of creating and maintaining more than one name node independent of each other on in an Hadoop cluster. Because normally HDFS consists of two parts. That's namespace and the block storage. So it's just so HDFS federation just to how to maintain and creating of this name node on each independent Hadoop cluster.
Okay. Thank you, Sunday. And that is it.
Thank you.
So HDFS Federation. So they don't call HDFS 1. So during the period of HDFS 1, well, HDFS 1 only has one name node. And when that name node goes down, there's inability for the other, let's say, worker nodes to keep working. So they are thought of how can we back up as much as maybe on the normal Hadoop file system, there's a backup for the slave. So they now say, okay, we need to have a backup for the master too. So that whereby we are going to have two name nodes. So that if one fails, the other picks it up. So and I said something when I was explaining HDFS Federation, I mentioned that okay, you have a manager in a bank or maybe in a company, and you have an assistant manager. So such that when the manager is working, he informs the assistant manager, see, okay, this is what we are doing. He gives the assistant manager updates. So anytime maybe there's an engagement or maybe there's any reason why the main manager needs not to come to the work to office, the assistant manager can easily step in and work seamlessly as if nothing happened. And I think that day I said something about when you go to the cloud, there's always this provision that when you have your main server, in case that main server goes down, there's always another guy that can pick it up. So, and I know I mentioned guys like AWS, Azure, but I understand this more with AWS, and that is the deal. So everybody, we are looking for a way at which our data on the internet or our data on a particular platform or on a particular infrastructure would, let me say, would exhibit fault tolerance attributes such that when anything goes wrong, we don't just lose our data. So there's something we call, so like we're talking about the federation is making use of having two masters, and those two masters can control all other primary slaves. So they can control the slaves. Both of them, the two masters share what they call the same memory space. So they share common memory space. So once the master is down, the other guy just step down to the memory space, updates their information, they understand which job is currently running on a particular node, what is the map reduce function that is executed. So they know everything to detail to what the previous guys know, and they pick it up from there. That's one of the big advantage of federation, HDFS federation. And
So I have a question.
right.
When these maybe these namespace are being replicated on another name node, can there be any form of duplicates? Maybe even one is, if one is deleted, and I actually want maybe everything, maybe after it has been replicated and I've already dropped one out of the namespace, can it actually be the duplicate still remain somewhere and it brings it back to life or something?
Please, please reiterate your question.
I say when these namespace are being replicated on another name node, or is it that they cannot be replicated on another name node? Let me even ask that question first.
So I don't understand what you mean by your own namespace.
Like each data node, something like that.
Okay.
Can they be replicated on another name node?
No, they are not replicated on that name node. It is that same. It is okay. Let me the visuals for the question. Let me see. So that I can use that to explain. Okay. I'll share you my screen now. Okay, are you seeing my screen?
Yes, sir.
Yes, we can see your screen.
Okay.
Sorry, your screen is
Okay. So each namespace, like you said, is like the master, the name node. So understanding that they share the same memory space. So any action, for instance, now, if name node 1, see, we have if name node 1 is currently working and is controlling some sets of data nodes, the process name node 1 is working on is inside pool 1. So pool 1 is like the task for name node 1. Like say, okay, like all the, you know what name node 1 we keep are the data mats of each of the, say, the other nodes, like the server nodes, the slave nodes. So there is no need for a replication on the namespace. If name node 1 goes down, name node 2 can pick it up, can pick the information of name node 1, because they are still on the same block of food. They can feel like, okay, now name node 1 is down, but we can still have the data map of name node 1, and name node 2 will pick it up and start from there and get the work done on other data nodes seamlessly. I don't know if I've answered your question, but if I have not, can you please ask your question in relation to what you are saying?
Actually, you've done justice to the question.
What do you say?
You've done justice to it. I understand it much more better now.
All right. Thank you. So, as I was saying, Sonia has made this justice to, we've talked about HDFS and the likes. So, it's always an interesting field to know, to understand all these guys and having the concept at the back of our mind. Esther, I want to ask you a question. That's Adetoro, right? Can you explain the architecture of how does data block replication works? And I want to ask you a question specifically. The question is, I think it was a question we asked in the previous class. And the question is, if a process is running on a particular block, will the process be replicated? That's the question. And you also tell us what's the architecture behind data block replication on different data nodes. Esther? I'm waiting. Is Esther there? So we need somebody to bail her out. If she's not there, maybe Esther, you're on mute too, in case you are speaking and we can't hear you. So it be time now.
I can't be out. I'll call you first.
You can't just be a friend. You can't just be a good friend. Like say, okay, a friend in need is a friend indeed. So at least be a friend in need. So either you choose to bail her out or you don't choose to bail her out. You answer that question. If you choose not to be a friend, I'll make you a friend by force. What is the concept behind data replication? Because these things are things we keep in mind. These are the core, these things are the building blocks of HDFS. And when we don't get them right, it's not just about the technical skills, about the soft skill, the soft knowledge we have on our hand. So what is the concept? I'm not going to ask you that question. What is the concept of data replication? Explain to us, how is a data, when I give a file I load a file to an HDFS environment, how do that HDFS manage that file? How is this replicated? What is the architecture behind it? So be time now.
I'm not sure.
Which topic are you guys on, analysts?
We are on R.
Okay. Okay, well, let me bail you out. I'll be the one to bail you out. No wala.
So, let's try, sir.
Iola, do you want to bail them out?
Okay, sir. Let me try. I'll
Okay.
try to build them out. Okay, sir. Okay. For replication now, that I think is because so if okay, the architecture is when you have in the HFS, when you have the name node, you also have the data blocks. So when the information on whatever it's or whatever the activity is, it comes to the name node. Name node replicates data across the different data blocks, so that just in case a data block has a failure or malfunction, it won't there won't be so to avoid single point failures like that. Okay, so once the data, each of the data nodes, data blocks, sorry, they send something like an heartbeat, I think every 3 seconds or something like that to the name node, which the name node used to verify the how do I call it, how healthy the data block is. So with those heartbeats sent to the name node also keeps a metadata of all the information that are in each of the data blocks. So if there's a failure somewhere, maybe a name node refuses to send a heartbeat or response to the name node. Sorry, a data block refuses to send a heartbeat response to the name node. Name node now, okay, there's a failure somewhere, and it's quickly call upon the replicated data And now to answer the question of if a process is running on one of the data block, will the process be replicated across other process be replicated? The answer is no. As far as the data block is working fine and is sending regular heartbeats to the name node, the process won't be replicated. This is to conserve resources, I think. Yes, it's conserve resources. So if the heartbeat says that okay, if the name node says that okay, there's no response after the process or something, then you can now use the replicate. I hope I'm not confusing myself. I think that's pretty much it. Thank you very much, sir.
Yola, sincerely, you did a very good justice to that, and that I think you gave a comprehensive explanation. So it started with the heartbeat. Like, is this name node active? So like in real time, just say pa 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 pa. So if the heartbeat stops, the system understands that I'm not going to give a responsibility to this particular data node. And the basic architecture is that files are replicated, data blocks are replicated. When you give a particular file to HDFS environment, it replicates them in blocks. It first breaks them to blocks, then say, okay, this particular block go to this name node and this like. So all those blocks reside at least on 3 replica servers, so on 3 data nodes, in a way that if one of the data block goes down, well, maybe the server holding a particular data block is down, the other replica picks it up and the job gets done. And you also answer the question that a process is only run on a block at a time. If name node 1 is running block 1, name node 2 will not run block 1. Name node 2 will be running block 2, such that when all of them are through with the map reduce job, they all send the reduce job to this master, or let's say the name node, and they get the job submitted and the client gets the result. So, and that is how it works, and that is the architecture behind data replication. So we should keep in mind all these things. These things are they are exam questions. They are going to come out, and the more we understand, the more we can just think through and say, okay, this option is odd, so this should be the answer, and based on the understanding, you get it done. So that's fine. So the next phase of our...
Please, I have a question.
All right, ma'am.
I don't know the question you asked, but I think I heard Daniel talk about data block or something. Maybe the last class, I don't know. You mentioned something like transaction. So I want to clarify, like, are transactions like the units of can I describe them as unit of data in a data block?
Yes. So like transaction, like you say you are calling it unit of data, yes, because it's just like a single row. When you have an Excel table is having like 1,000 rows. So each row is a transaction on a transaction table.
Okay, sir. Thank you, sir.
Yeah. Okay. Any other question? Please feel free to ask questions. Okay, so moving forward, we talked about map reduce. Now, and we have like 6 phases of a map reduce job. 6. So we just want to understand the whole concept of map reduce in just explaining. Though we know we have a lot of processes, we have a lot of advantages, description of our map reduce. So now, somebody's owing me a question. Marvelous has spoken. Ebube, explain in detail. Teach us, what do you understand by map reduce? Tell us the processes, the architecture of a map reduce job. So how does MapReduce work? So everybody.
Hello? Yeah.
Hi.
So basically MapReduce works like in line with HDFS. Basically they work on the same platform and it collects data from the HDFS um, and then takes it for processing. So basically what it does is it breaks down the data or it splits the data set and shares it based on one or two properties. Splits the data set basically to different nodes in the system. So that's the mapping aspect. So it maps them to these different nodes and gives it to them. So those ones then the nodes then process the data set that is given to them and then separates or analyzes them according to what one particular condition. So probably it's checking for a particular word that is present or something like that in all of them. So basically, after that, it now does a shuffle. So when it shuffles all this data between all the nodes, shuffles them according to the particular word. So if you select a particular word, for instance, maybe it's the data set, what is checking for, one node is checking for Ebube, one node is checking for Edward, one node is checking for Adeto. So, and all like that. So basically, when it now splits all of them and shuffles them according to these particular names, then into the reduce aspect. So the reduce now collates all of them based on these different names. It collates each and every one of those data sets into itself. Then there's now the count area. The count aspect now counts all the data present in all of them and presents the result eventually in an organized cluster finally. So basically that's what the MapReduce architecture, that's basically what it does in essence.
Okay. So I want you to complete these steps. We have like 6 main steps in the MapReduce process, starting with input. So after input, what next? Everybody, you're still having the question, or you are still the one on the other seat?
Okay, after input, you have splitting, the split.
So after splitting, what do we have?
You have mapping.
After mapping?
Shuffling.
After shuffling?
Reducing.
Okay. After reducing?
Then the results.
Okay.
The answer, the results, the eventual result you get from the.
Okay. Okay. So now, where does combiner? We talked about combiner. So what is the function of a combiner?
Okay, the function of a combiner basically is the reducing aspect. So it combines all the shuffled. After the shuffling step, when you separate all the data set according to the particular condition you are checking, so it now combines or it does the reducing aspect by joining all the data set and counting the number of them that's present.
Okay, that's fine. So I just want to help you polish that part. So now, they call a combiner is like a pre-reducer that does a first level reduce function before pushing into the main reducer. So it's the one that reduces the number of records, let's say number of key values that is passed into a reduce function. So it comes between, though it's optional, but it is always
You said the number of p-value.
Key value.
Oh, okay.
Key value. So we know we have a key value pair.
Yes.
So it's just an intermediary between a mapper and a reducer. So out of mapper and a reducer, which one of them is optional?
Reducer.
Reducer. Okay. So that's fine. So giving an overall view of how a map produce work. A map produce it's like what he said. All of us we did our hands-on on this guy now. Word count. You see how the map class is written, how the word class is written, and how the count class is written. So the count class is just like the driver, so that manages both the mapper and the reducer. So, and you see when you after initiating the process, you see it if it's a very large data set. I think there was a time when I did mine, I got an external data, not the one Daska gave to not the one Daska gave, and you discover that if you are having a large number of data sets, if your file is heavy, it's going to take a lot of time for it to complete. So at that process, you see how the mapping function is speaking from 10%, 20%, and coming up. So down to the reduce function. So that's we see that we have the mapper and the reducer, and we understand the background behind it. So, but the best thing is for we being able to write our own. So I think last week we talked about customizing map reduce function. So now how do we customize a map reduce? Because there are a lot of things behind map reduce, and we talked about, though I said this class is mainly practical, but I will reiterate on this class. So we talked about customize read files. So you know normally you are reading text file, so your reader can be customized, and that's what we talk about in a case whereby you are reading files that are high compute files, like we talked about say image recognition files. So things like that are they are high resolution files that's going to utilize a lot of compute capacity of your machine. So, and we talked about customizing even your output file, which we said you can decide to customize to say either you can connect back to a database, or you connect it back to a CSV file, or you connect back to any format you feel you need to write it. So, but before I continue, has anybody, we've worked with Python, right?
Yes, sir.
Hello? Aside CSV, have you written to any other data type aside CSV? Because I know we are used to write, how do you call it, pandas. We say, okay, write to CSV. So do you know we can write to other data formats?
Yes.
Yes, sir.
So
I know, yes.
that is the same methodology behind customizing the map reduce function as your normal R. And I said it last week. I said as your normal R, we pick from say CSV, or you read from a particular table, or you read from text file. Likewise, you can customize your map reduce job too to pick from a particular file format. And those file formats, all you need to do is just install the necessary how they call it packages. Likewise, the necessary library that will make it readable. So once you're able to read it and you pull it to environment, you do your MapReduce job on it, then you can also say, okay, let me then write it to a particular format which will be usable by you. And we gave a lot of example of output format. We talked about you can write it back to an H base. And most of the time, I said, most of the time, the most interesting part is you write it back to an H base because you want to write it back to a database that so that you can now run your query on it. So because MapReduce files are maybe files that are very dirty, but you want to make those data structured, and after structuring them, then you take it back into a particular database whereby the analytics team can work on it. So you understand that the data engineer are the guys between the data warehouse, let's say the raw file, either structured or structured, semi-structured, and the database where the analytics guys will be working on. The analytics guys sometimes they don't care about what happens at the back end. They just feel like, oh, please, we need data. I can tell you, a data engineer does the data job at the background, but a data engineer that understands analytics will do his job better than a data engineer who does not understand analytics. And a guy who is into data analyst that does not understand data engineering will not understand how to get his variable. Now, if the data engineer gives him a data that is not fine for him, he will just feel like, okay, I'm running analysis on this thing and I'm not getting results. That's why it's good to have understanding of how do I understand the analytics part and the data engineering part. In our current project, currently I work as the data engineer. Because I understand data analytics, by the time, maybe previously, if they want to perform analytics, they make use of, let's say, I saw, before I got to the project, they performing analytics, they make use of, let's say, they create almost like, say, 7 tables. But when I got there, because I understand analytics and understanding data engineering part, I only give them 1 table that will be sufficient. So, likewise, on MapReduce, once you understand all your inputs very well, you know how you reduce all your tables together and how you give it the best output format. And that is the big deal, especially the output format. If your data is not outputted, you don't have an output for your data file, then it's not usable by data analyst guys. So we have customized output, and it's always a good thing to work with. So we've talked about the combiner that is in between the mapper and the reducer. So that's the guy that makes the job easier for the reduced guys. So, and on the reduced part, so as we said in the previous class, it's the job role of the reducer is just to calculate, just do aggregation of the data sets you've worked on. So there's always an aggregating function on a reducer. Like either you are working with sum, or you are working with counts, or you are just taking directly from, but most of the time it's always aggregated. So we are counting the number of years, number of male in the data file, number of female, and you are inserting to a particular table. Then that's that. And we also have the final part of our MapReduce job, where we talk about the result, and that's what I've been hammering on, that we have lot of data formats that our reduced job can, our result can work on. So that's that. I think that's the overall knowledge about a customizing map. We can just go back and please do a refresh, and at least please answer all the questions at the end of each modules in your lab material. With experience, those questions they have high propensity or probability of being one of the exam questions, and those questions are questions to give you a grounded knowledge about what you're doing. So we have what we call testing map reduce job. Let me see. I'm coming. So as I said, this class will be more practical, but we'll just go through some basic things on how you can test and debug a map reduce job. I know Timlola has done a lot of explanation to testing a map reduce job, but we'll also go through what we have on our presentation for this week. Okay, I'm going to share my screen. Is my screen visible?
Yes.
Yes,
Yes. Okay. So testing and debugging our map reduce application. So the objective of this class, which will be tested on in long run, is perform unit testing and map reduce application using MR units. We're going to get into that. The local testing of map reduce application, the logging for Adobe testing, the report metrics with job counter. Yes, so when you run a map reduce job, you always see what we call the job counter. So counting the number of jobs that are successful. They implement defensive map reduce programming. So let's speak one by one. So now we understand that in any application development, all of us, at least, we've had a hands-on programming experience. And anytime you finish writing a program, there is always like, I need to test this code. I need to be sure this code is working. So code testing is an integral part of code development. So it's something every one of us do every time we write a code, and that is what we also do on a MapReduce application. So it's not that we just deploy a MapReduce application to production without testing it, at least testing it with a little data set to be sure that it's working. They said, programmers implement test-driven development, a programming technique that requires you to write actual code and automate code tests simultaneously. Majority of MapReduce implementation can be tested using the JUnit framework. MR unit is a unit testing framework designed specifically for Adobe. So like that's the MapReduce unit. So you see You have the Java unit framework, you have the MapReduce unit framework, which is used in testing a Hadoop, a MapReduce job. So he said, also understand that the MapReduce unit is based on the Java unit and allows for the unit testing of mappers, reducer, and some limited integration testing. So there's always a need for us to test our code. And we can make use of Eclipse in testing, and which is a good platform for us to test our, which has a MapReduce unit that tests a MapReduce job. On our next slide, said the standard MapReduce Maven POM file must be extended by adding MapReduce unit dependency for implementing a MapReduce unit. So now the MR unit, so you always see what we call, when you're writing your MapReduce job, always see what we call the extension. When you're extending a particular package. So likewise, we have an extension for you need to extend your package on MapReduce unit. So sorry. So that will be the guy responsible for making sure the MapReduce job is running effectively. So we can see a sample program of a MapReduce job. You see the JUnit extension. See, we have our JUnit. We have the Apache MapReduce extension. So these are guides to test our program. So, and we'll have and this is going to Akomolafe and Ebube. We will have our kit, and we are going to review the code and see how these guys work. So so we also have some MapReduce image testing. You see, you said, okay, test public voice. We are testing the mapper. So this is just like a MapReduce test environment. So it's like the way we write our normal mapper, where we define the inputs files, and we get our key value pairs. So, but in this case, it's working on and so which was best, and if we are good to go. Okay. Okay. We said the application programming interface style of coding enhance the ease of writing a MapReduce unit based on unit tests for the mapper. The limitation of a map driver class, the program, is that it provides a single input and output pair per test. So that's that. So every MapReduce driver, doing a MapReduce execution, we have the mapper user and the driver. So when the map driver runs, the output is just like you have the input and the output like a key value pair. When you are, so the output, like your word count, the output will be in rows, whereby you have, okay, you're counting number of years in a particular document and say, okay, yes, it's 20. So he said those the width input and the width output have to be called multiple times. So each line is just like a loop that picks each line and writes them. So it said the map driver implement overrides the existing values with the new ones. So only one input output pair is tested at a time. The map reduce driver object must be used to specify multiple inputs. So these are limitations of a map driver. So this can be corrected, or we can solve this challenge when we have a tested application and we are sure that the output of our map reduce is efficient and is working efficiently. So we can avoid all these errors. Writing a map reduce job that is well optimized and that is having the results which we need. Reducer driver has the same limitation as map driver of not more than one input. Reducer from this example are passed as parameters for testing. So we can the data engineering guys. It's very uncomfortable for us to understand at least the basic of Java programming. Okay. Integration testing. So before deployment, you can integrate the MR unit into your MapReduce job to help test and help manage the MapReduce job to be sure that the codes are well written and also to overcome the possible limitation of a map driver or a reduce driver. So the MapReduce provide the MapReduce driver and reduce driver. It said first the input and the output type, the end input and the output type of the user are parameterized. The overall output in 3 pairs of parameter type. Additionally, multiple inputs can be provided and multiple expected outputs can be specified. So when you are working with, you can have multiple parameters, unlike when you are not having a map reduce driver. You can input the key value pairs like you have the parameter key, you have the value. So the parameter is it's just like let me say a dummy variable that gives room for multiple entry. So in case you have duplicates, it is indexed in such a way that if the first key value pair picks parameter 1, the second will pick parameter 2. And in such manner, you can retain a lot of key value pair and the process running in multiple times. The process will just run, let's say once, and based on the parameter, works more efficiently and less time for computation. So we still have a code, please, page. Oh, okay. Sorry. I said, with configuration and with combiner can be used to test configuration and a combiner if required. So we have what we call, we talk about the combiner, and we talk about the configuration, which is found inside the driver. So said instance of the mapper and the user are passed. So, and that is what we have here. You see text map reduced. So in this case, how many parameters are we having here? 1, 2, 3, 4, 5, 6. How do I put it? Okay, starting from what we discussed here. So the overall input parameter, the overall output is three pairs of parameterized type. So now if you, maybe in previous code, in the normal MapReduce code, the parameter you have here will just be 4. So that is maybe 2 for the input, the key value pairs, and 2 for the reduce. But in this case, in a test environment, so when you are testing both the map and the reduce together and you are getting sure that it is working fine, you see a 6 parameter input file on the MapReduce driver. You see the long writable. So you see text as the key and text as the output as the value. We have the int writable, the text. The text is a key, and the int writable you store this in form of count. Like when you are counting your count, your normal count. Though you can change it to text, but this suffices integer. You are counting maybe a set of occurrence. Okay. So the MapReduce class enables passing in multiple inputs that have different keys. If a test fails, the output of the MapReduce unit produces states. So when you're working with C# too, and maybe you write a package and you initiate the package to run, and after the run time, you discover there's a failure. There's also an explicit error message statement that tells you where the error is coming from. Likewise, that's what a MapReduce unit does too. It explicitly tells you, okay, this is where the error is coming from, so that you can easily debug and fix the error. So now, testing a developer compared with testing challenges on other IT domains. Can we discuss this? So, like, based on all we've been hearing, so what are the possible testing challenges you feel like? Now, I know maybe you might not have experience about software testing. Because software testing it's a unit in any say or software department whereby you need to, when you are deploying a software, need to test it. But what we are talking about here is your normal, even testing your normal simple code. Now, what are the challenges that we testing on MapReduce we're going to face, like guys on the big data ecosystem, we're going to face, aside from guys on the IT department? Do they have anyone who has idea of possible challenges that we might possibly face during code testing? And if there's anybody that can help. I'm waiting.
Okay. Okay. Let me tell you one of the challenges that a big data developer will face. Other developers, they have a more structured data. Like their data is structured. They know where they are going. Just like when you're developing an application, they have a closed environment, and you know you can easily write, say, okay, this is what I want to do. But as a big data, for different for different kind of solution, you'll be facing different challenges every time. In the other IT world, if you are building say a mobile application, and if you are good on building it, you can say, okay, yes, I know how to build it. And when you have errors, we can say, okay, this I have somebody that can, or let's say go to Stack Overflow, and you get things done. But as a big data, because of the peculiarity of individual data, which is influencing the various MapReduce functions and objectives, it's going to be a bit difficult. So when testing, there will be a bit challenge than a normal IT guy, and especially when you're working with unstructured data sets, and you need to do a lot of computations, especially when you are doing hierarchical, when you have multi-level jobs before the reduce. So the first thing, it's a bit difficult and tasky, and when you are having lots of map class to test or to call into a single reducer, it's always a bit challenging. Okay, tell me. Okay, local application testing with Eclipse. So you can also test with Eclipse. It's saying developing an Adobe program in Eclipse provides the capability to run complete MapReduce application on a single instance mode. The Adobe distribution comes with local job runner. The single job runner lets Adobe run on a local machine in a single Java virtual machine. So before you test it on the main system, you can run it on the normal virtual machine. So that is one thing we can locally test. So we can test it on our environment and be sure we are. So can test locally, as I said earlier, that we can test locally with Eclipse, and and NEXT-based local execution works on both Windows, and by default, a local job runner uses the local file system for the read and write data. So we can test locally before we push into deployment. So with that, we know the status of the process we are running. Logging is used in a majority software project and serves many important purposes, including creation of execution audits trail that we can be used later of previous purpose, collection of execution metrics. So and is do you have anyone as a computer science student here who study computer science? Any computer science students in the house? Because they will understand, because this is looking like me speaking another language. None of us study computer science.
I think
Do
the
you have
majority.
anybody who studies
Yes.
computer science? What do you say?
The majority of us are engineers.
Hey.
No, there's no. I don't think there's a computer science person. I'll see.
Okay. So, if assuming we understand software testing, we would have understand what I'm saying better.
No, you can proceed. We'll probably research or data ourselves.
So no problem. We'll understand all these things as we go little by little. But it's just a procedure of testing our application is working. So when you are testing an application, you say, okay, when you are building an application, you build it in batches and say, okay, maybe this first code should do this. And after writing those codes, you test it and be sure it is running. And especially in Java, whereby you have multiple classes, and each class one can test it sequentially, and each class is executing, and the corresponding output for a particular class is into the other classes. So, okay. So defensive programming MapReduce said Hadoop runs on a vast number of input record. Thus, it is often a counterproductive to kill a job every time a mapper cannot process an input record. A reliable application is one which can tolerate skipping some of the input data. Unfortunately, such an implementation is non-trivial. The methodology, or let's say the architecture behind Hadoop programming, it's not productive when you say when you schedule a job, a MapReduce job to run, and
and anytime the job fails, you say, okay, just kill the job. No, it doesn't kill. It keeps it in memory. So maybe in our practical class, and we are going to see where it is stored, and it's going to tell you, okay, how many trials does it have the job to before the process was able to execute. It's not productive to kill a job every time a mapper cannot process an input record. Maybe you're asking the map produce job, the mapper to process a particular input and is unable to compute it. And okay, if you can do like our normal programming languages, it will just kill it and say, okay, job failed. But in this case now, it is rescheduled to run. So a reliable application is one which can tolerate skipping some of the inputs. Like, okay, so understanding this, when you work with SQL, there's a package on Oracle called SQL LLDR. So if you're asking that package to load in a file, you can tell the package local so the file will keep loading the rest like something. Okay, I've seen it. Actually, default is like 50 errors. So it keeps some input data. If it feels like the data structure, it keeps it and keeps loading. So that is one of the feature of MapReduce to let's say a defensive programming, whereby you set a job not to always terminate a MapReduce job, not to always terminate. So I said, okay, and the mechanism for communicating with the mapper to report reader error so that the mapper can correctly output the information about them. So this is also applicable to other data loading mechanisms. So said said error handling in the mapper. So the mapper is the first phase of the execution. So most of the error comes as a report. Sorry, went off. The map function is the guy that is the first guy that sees the input data and Oracle data loader. So when so all the possible stuff that are not meeting the entry that are not meeting the required table structure, they are pushed into the bad file. So it's the same architecture that MapReduce works on, and you can carefully handle the error, and it's going to tell you which error, why is this guy throwing error? Is it that the data type that is expected is not correct, or probably the specified length of a particular variable is not what it should be? Then it throws up an error. Set custom output format. What write error data is the dedicated error output directory. So what is have a directory whereby the errors are written into. Okay, let's go to other questions before we call it a day. Okay, before we call it a day, there are a few things you should put in mind. And if you forget every other thing, keep this in mind. One of the cornerstones of a test-driven development is unit testing. Majority of MapReduce implementation can be tested using the Java unit framework. So when you are using a test-driven application, it said the unit testing is one of the cornerstone. We can't overemphasize it. And the MR unit is a unit testing framework designed specifically. So what are the frameworks specific for testing? It can also be used for testing mapper and reducer and map reducer. So, and you have what we call the MR unit provides the MapReduce driver class that enables to test how a mapper and a reducer are working together. The MapReduce driver also parameterizes different than mapper driver, and we'll talk about the three output formats, the three outputs key pair. Like in the normal reducer, we have two key pair, maybe the key and we have the key value pair, the key and the value. But on the MR unit, we have the three parameter value key pair. So using Eclipse for Hadoop development provides the capability to run the complete MapReduce application locally. Yes, so that those are things loading from me. Well, what do you say? You can't hear me well. Oh, sorry. That should be my network. Sorry. Apology for that. So we are still on our point to remember. Logging is widely used in a majority software project and serves as important purpose, including the following. And we talk about the creation of an execution audit. So talk about collection of execution metrics. So how do I know if a particular execution is giving me the right output? So you have a metric. So if we are expecting a particular range of value, then if the output is within this range, then you feel like, okay, my job is working. So that's what they call logging. So log of all important events of MapReduce execution are saved. Yes, so the MapReduce logs can be seen at the log folder. Because Hadoop runs on a vast number of input records, some of which can be corrupted, it is often counterproductive to kill a job every time a mapper cannot process an input record, like we said earlier, either because of itself is corrupted or because there are bugs on the map. So those are things we need to keep in mind. Finally, application can control the skip over bad record range features through the skip bad record class, which provides several static methods. Hadoop finds the skip range useful using a divide and conquer approach. Skip bad record is a class that gives you to tell you that, see, if the case the input records are not meeting the specific formats set by the mapper, then skip it. I said in Oracle, we will call it errors, permissible errors. So when the input file is not meeting, it says, okay, you can skip it. And the approach map, I don't make use of what called the divide and conquer. So it breaks the file to bit and make sure it tackles them one at a time to be sure the records that are coming in are well classified. Those that are good, they are ingested into the system, and those that are not meeting the specific format of the input reader, they are ejected. So thank you very much. We can have a question. So I have 5 minutes in case you have questions. Any question?
Yes, sir.
Oh yeah.
Okay, sir. Sir, I would like to know, does the local application testing with Eclipse, does it have a limitation, or to better put it, what advantage does using the MR unit based testing have over the local application if you get the same results? Or is
No,
there a difference in the results we are going to obtain? I don't know
okay.
if you got my question, sir.
Yes, I got it.
Okay, sir.
So MR unit is just a framework for
Okay, sir.
testing Java, like say a MapReduce job. So now, so what we are saying is that on Eclipse has that same unit, such that you don't need to run it on the main. Once package understand that this is a test process, it doesn't distribute it across all the nodes on the Hadoop display file system. So it tests it locally as you can have okay, let me put it this way, or let me say, do you know MapReduce? I know one on our previous classes we said for every MapReduce process, there's something that is created at the background. They call it Java virtual machine that is open and closed. So anytime you want to run the MapReduce job, you have a Java virtual machine that runs the job. So now, once it is a test environment, that JVM will be created locally on your machine to test the simplicity of your code. And you know, even when you are testing, you are still going to pass in some input file. So it's not going to run it on the large scale, but it's going to test it on, say, locally. Let's do it let's do it within our test environment, because we have a test. We always hear what they call the test environment and the deployment environment. So for this now, once we have the test class on the Eclipse, then it's going to work locally. So it's Eclipse has a provision to test it locally and be sure there's no error. So if there's, it's just like let me say, when you are running a Python code now, if there's error on your Python script, you'll be seeing red line. So currently now, what that guy is doing is that he's testing it line by line, telling you, see, maybe you called a class up there and you not make use of it, or you are specifying a variable that is not defined, you see a red line. So it's just like that's the same methodology behind the MR unit, which enables your Eclipse system to at least run it in the background to be sure if what you're writing will compile, or probably the process will execute properly. So that's that. Hello. Okay. So thank you very much,
Yes,
everybody. All right. Thank you, everyone, for your time. On Friday, we'll be having our practical class. Friday will be a practical class, and we'll be having a practical session on Friday. And that's where we're going to have a grounding knowledge of what's happening. And I'm very sure that as we move deeper into the class, you see that it is very simple. Yeah, it is very simple. It's just because we're just 13 and it looks as if this thing is tasky. But when you get to understand the basic and you move in, you saw it's simple and you will enjoy it with time. So thank you very much for your time. So enjoy the rest of your day. Yeah.
Thank you very much.
okay, guys. Guys, take care. Bye.
Ibitamuno. You're still here. Bye bye, you. Have a nice evening.